Oh, hi there. Thanks so much for showing up for your math learning. It's Mr. Jennings. And this is what we're going to be watching in class, so I'm pre-recording the lesson. We actually have permission from the Minister of Education to watch these games, so we're going to take advantage of that. So here, we're looking at our final topic of the unit. We want to be able to solve polynomial equations. And solving polynomial equations is it's going to use all of the skills that we've looked at already. If you can factor, if you can use quadratic formula to find the solutions to something like x squared minus x plus 3 or something like that, then you're going to be able to solve polynomial equations. Let's go. You want to be able to factor and solve. You want to be able to sketch them and understand their intercepts and end behaviors and the connections between something like this, where you have a cubic function with roots. And then when I say, well, if p of x, this function equals 0, what does x equal, right? Well, x would equal these values, because that's where the function has the value y equals 0 down there. Okay, let's go. Let's keep going. All right, so I'll post the delta math shortly. You'll be able to practice. And we talked about this. And we're still going to be using this like setting one side of the equation equal to 0 skill that we use with quadratics. That's not different. And the idea of factoring it and then setting each factor independently to 0 is the same as it was with quadratics. So that's nice, isn't it? Okay, let's try this one. So here, we know that this polynomial is a function, but it's equal to 0. And so then we want to know what values of x would make this true. There could be as many as 4 different values of x that make this true, and we're going to find them all. So we want to know, like, our potential factors here are the factors of 6 and plus or minus. So these are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So we're going to test all of those. We might even be divided by the factors of this, so that's also ditto. Welcome. So let's test and see which one works. Okay, so the first thing that I test is x equals 1, and so that would give us 6 plus 1 minus 22. No, it's way too negative, so I just stop. Just stop. No, it's not going to work. Now let's try minus 1. So minus 1 would actually change the sign of this one, and it would change the sign of this one. And then we've got 6 plus 11x. So that would give us plus 23 minus 23. That is 0. Okay, so that's how I would find them. You just go ahead and find it. All right? You find one that works. So I've found that when x equals minus 1, that's definitely a factor. That's one of our solutions. Now let's use polynomial long division to divide it out. So we recall that we flip the sign of that. So I'm going to have x plus 1. So that's x minus minus 1. Dividing into 6x to the 4 plus x cubed minus 22x minus 11x plus 6. So the first thing that we'll do is multiply by 6x cubed. We are subtracting all that, so we end up with minus 5x cubed minus 22x squared. Yeah. And then we're going to multiply by minus 5x squared. So we have x cubed minus 5x squared. We are subtracting all of that, so we get minus 17x squared. All right, drop down this minus 11x. gives us our happy face remainder, 0. So draw your 0 really big. Put your happy face in there because we're really happy that we got 0. Okay, cool. So now we know this. This is equal to x plus 1 multiplied by 6x cubed minus 5x squared minus 17x plus 6 equals 0. We're still on the hunt for 3 more factors. Okay, so let's find them. So now we test this one, and if I check -1 again, like 1 was not a factor before, like up here, so it won't suddenly become a factor here. But conceivably -1 might be. We might have a -1 squared root, and that would be useful to divide out. We'll know more about it then. So let's take a look. If we have -1, that would be -6 minus 5 plus 17 plus 6, and that's way too positive. So -1 didn't work. Let's try, so we had that once but not twice. So let's try 2. Okay, so I would do this in my rough work somewhere. 6 times 2 cubed minus 5 times 2 squared minus 17 times 2 plus 6 equals, this is 48 minus 20 minus 34 plus 6. Ding, 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 ding. So we found x equals 2 is another one of our solutions. Remove your rough work. We don't need it anymore. That's not like an important part of your communication, but if you have an error in there, it can be very problematic. So do that carefully. So now I know that I can divide by x minus 2. I'm going to divide, I just need some space here. Right over here looks good. X minus 2 dividing into 6x cubed minus 5x squared minus 17x plus 6. Again, we get this happy remainder face, so we're pleased. And we go ahead and rewrite the problem. X plus 1 times x minus 2 times 6x squared plus 7x minus 3 equals 0. Okay, keep the flow of your solution nice and tidy. Now, I'm no longer thinking about like, what are my potential factors? I'm done with that. I'm now going to factor this as a quadratic. Okay, so 6x squared plus 7x minus 3. Write that as your rough work somewhere else. This factors this way, 6x squared plus 9x minus 2x minus 3, because we can multiply to minus 18, which is 6 times minus 3, and add to 7 in this way, 9 and minus 2. So I use these numbers to break that middle term down. That allows me to say, group this. This is 3x times 2x plus 3 minus 1 times 2x plus 3. Okay? And then that factors this way. It's not good. I need to plug in x plus 1 multiplied by x minus 2 multiplied by 2x plus 3 multiplied by 3x minus 1 equals 0. Last thing that we need to do to push this question across the finish line is say, therefore, x equals, list them smallest to largest, x equals minus 3 on 2. That's this one is 0. Minus 1. 1/3, which is this one is 0. And 2. Okay? And we can write that as a set like that. There's your solution set. Those are the values of x that make this true. Now, notice, we had 1 on 3 and minus 3 on 2. And both of those could have been predicted by looking at this in here and saying, well, we might have been plus or minus 3 in the denominator or plus or minus 2 in some combination, like 3 divided by 2 or 1 divided by 3. So they are also there. Hey, it's 1, 2, 3, 4 o'clock. All right, let's keep going. All right. Okay, let's hide me here. Read that again. Okay, so now this one, oh dear, we've got junk on this side. We really want that to be 0. So we use our inverse operations. Maybe you write it this way, minus 2x cubed from both of these. And then we're going to add 2x squared. And then we're going to subtract 5. That's the way I write it down. So then our problem is now 3x cubed plus 9x squared plus 5x minus 2 equals 0. Very nice. So now we investigate our possible factors. And we have here plus or minus 1 and plus or minus 2. Okay, so it's one of those 4. All right, if it's anything. So checking the first one, if we have 1, clearly doesn't work. So let's try negative 1. 3, negative 3, minus 5, minus 2 is negative 10, plus 9 doesn't work. All right, and we can also see 2 won't work because all of those terms would be positive except for minus 2. So let's try minus 2. Okay. So I'm highly suspicious that minus 2 is the solution. 3 times negative 8 plus 9 times positive 4 plus 5 times negative 2 minus another 2 equals, what does it equal? Negative 24 plus 36 is positive 12 minus 12, 0. Okay, so there it is. So it is positive 2. Yay! So we found it. Remove your rough work. I wouldn't do my rough work right there, so I was working in pencil because I can perfectly erase here on the computer. So now we're going to divide that in. So we have x minus 2 dividing into 3x cubed plus 9x squared plus 5x minus 2. And then we're going to do this a little quietly. It was negative 2. It wasn't positive 2. Oof, I almost made an error there. That would have been sad. I don't want to make an error. I want to get this right. So I have here, this is plus, and this is not 15. This is 3. Okay, so now check my work. Because I have x equals minus 2 as a solution, that means x plus 2 is a factor of this polynomial. That's what I'm dividing out. So now we get 3x squared plus 5x, and so that we're going to multiply by plus 3x. Minus 1, and that indeed cancels that out, gives us our happy no remainder face. So this is equal to x plus 2 multiplied by 3x squared plus 3x minus 1 equals 0. And then a quick check shows me that while it has roots, does not factor. I know this has roots because it has a positive discriminant. So the discriminant is this part of the quadratic formula, And then if the discriminant is positive, then we have 2 unique roots. And that's indeed the case here. I quickly did 9 squared plus 4 times 3 times 1. Why is it plus? Because it's minus minus. And that's a positive number. So now we're just going to quadratic formula that. Again, that's rough work, so do it somewhere else. X equals negative b plus or minus the square root to b squared minus 4ac over 2a. Mr. Jennings is amazing because he has that memorized. The reason he has that memorized is he writes it out every time. So those of you who don't have it memorized and aren't writing it out every time, that's your problem. And there's our other 2 solutions. Okay, so we found 3 solutions. All right, so then we just have to say, just finish this problem. Therefore, x equals minus 2 comma minus 3 minus root 21 over 6 and minus 3 plus root 21 over 6. Done. Those are our solutions there. Cool. Let's keep going. I'm sighing because I almost want to skip this example, because this example, you've already seen me done many examples, and this one, the catch is we can take out 2 factors of x and then we get 2 factors times a quadratic, but the quadratic is going to not have any roots because this would be a negative number. So we only have 2 solutions here. Just because it looks like a 4th degree doesn't necessarily mean we have that many real roots. We can have fewer. We could have as few as 1 or 0, and still that can be our situation. In this case, we have 2. I'll circle back to this one if I have more time. I really want to get to this example and walk you through this example because it's an application of this type of stuff, where we have a rectangular piece of cardboard that's 24 by 30, so it's almost squarish, and we're going to cut squares out of the corners and then fold those up to make a box, an open top box. We want the box to have exactly this volume, so we want to know the size of squares to cut out. So if you thought drawing a diagram is beneath you, get out of class. You're not welcome here. Okay, draw your diagram so that you can organize your thinking. All right, so here, 30 by 24. There's our cardboard. And we are going to cut these squares out of here that are x by x. And then fold along our dotted lines here. That's going to be the base of the box, and then those are going to fold up to be the walls. X by x. Okay? So, what does that give us? This gives us 30 minus 2x is this dimension, and this dimension over here is 24 minus 2x. So, we have what we need to build our volume equation. Volume equals 1040 centimeters cubed, but it also equals x, because that's the depth of the box, multiplied by the length of the box, multiplied by the width of the box. Do you like life to be easy or hard? Me, I prefer easy. I know that will surprise a lot of you, but I like going easy on myself. So when I spot a common factor here, I factor it out. So that's x times 2 times 15 minus x times 2 times 12 minus x. Okay, so I factor those out, and that's equal to 1040. And then I'm going to go ahead and do this thing where I can divide both sides of the equation by 4. All right, that's totally allowed. So 1040 divided by 4 is 260 equals 2 times 2 is 4, so those all cancel. X times 15 minus x times 12 minus x. Let's expand and simplify so that we can set this equal to 0. Okay, so 0 equals 15 times 12 is 180. 15 times minus x times minus 12 is minus 27x plus x squared minus 260. Final simplification gives us this is equal to x cubed minus 27x squared plus 180x minus 260. So that's what we're factoring in our next one. One moment. Oh, hold on. Okay, let's keep going. So here. So let's take this to another page. So we are interested in factoring this expression. X cubed minus 27x squared plus 180x minus 260 equals 0. And I want to now investigate the factors of negative 260. And I find that those are plus or minus 1, plus or minus 2, plus or minus 13, plus or minus 5, plus or minus 10, plus or minus 13, plus or minus 26. I'm going to have some limits on my x as well, but we'll talk about those in a moment. So, possible factors. Let's test these. Clearly 1 doesn't work because we're minus 80 over here, and that's a lot of minus that this can't overcome. Okay, so that didn't work. But what if we tried something like x is 2, right? Negative 1 also doesn't work. We'll quickly see, like, if we flip that and that to negative, everything's negative, so that doesn't work. So let's try 2. So if we have x is 2, then we are 8 minus 27 times 4. 27 times 4 is minus 108. So that's looking pretty good. Plus 360 minus 260 is 0. X equals 2 is one of our solutions. Great. All right, so let's divide that out. So we have x minus 2 dividing into x cubed minus 27x squared. Let's go. X squared. Cool. This is so much fun. Okay. So this is equal to x minus 2 times x squared minus 25x plus 130 equals 0. And now we might try an x game, right, where we want to multiply to 130 and add to negative 25. But we'll find numbers like 13 and 10 just don't quite cut it. And that's as close as we can get to 25. But negative, right? Negative numbers. Doesn't quite do it. And we can't get any closer than that. So it doesn't factor across the integers, so we need quadratic formula. This is why these were invented. This is going to be a nice one. So I use this little cheat sheet here. A equals 1, B equals minus 25, C equals 130, and so we have x equals negative b plus or minus square root of b minus 4ac over 2a. Okay, sing it every time. Four times 130 is 520. For 2. Okay. One hundred five has no square factors, right? No, it's divisible by 3, 7, and 5. So no, that doesn't reduce, like we can't simplify that. So it's just this. And then, so that's like a little bit bigger than 10, right? 105. So let's find them. So 25 minus root, there it is. This is an ugly calculator. It's also got a lot of things rubbed off. Root 105 equals that. What? No. I'm going to do it on my calculator here. I'm going to do it on Desmos. So let's go. Yeah. So we are getting a Desmos open. 25 minus SQRT 105. Put it in brackets, divided by 2. There. So we have this one, 7.37, 7.4. Okay, so that's the value of that one. X equals 7.4, or I'm just going to flip that one sign. Isn't this nice in Desmos? You can just get what you want. 17.6. Wait a minute. If we cut out squares that are 17.6, that would mean that this came in so far that those actually crossed and created negative dimensions. 30 minus 2x would be negative, and 24 minus 2x would be negative. But a negative times a negative makes a positive. But even though that's true, it doesn't make any sense. You can't have a box with negative dimensions. So we have to throw that solution out. This one is inadmissible. So, therefore, so that's how this one do. Okay, so that's how you solve these problems. Practice these ones. There'll be delta math on the quadratic formula as well. And I wish you very well. Thanks so much for showing up for your learning, everyone, and for cheering on Canada during our class, which is in 7 minutes, 8 minutes. Okay, bye for now, everybody.